All right, so an interface in Java is just a collection of related methods. So I have this interface that I call point. Notice how I've just named these methods. I haven't written any code for them. All of these are probably going to be overridden by some class. It's just that I'm defining them here. This is my interface. So some classes that might implement point could be like rectangle, triangle, circle. Um, Student probably won't implement it because the student doesn't have an area or a get x, get y, and stuff like that. The class that implements this point interface or uses it, it can have additional methods, but it has to include all of these. So in order to implement this interface, all of these have to be used. So I have this abstract shape. Now notice I'm using the abstract keyword. This is public and it implements point. So in my abstract shape, you'll notice that I have all of those methods at least defined. Now, I haven't written anything because I guess it's going to totally depend on what class is calling this, how I would find the area. So this is just defining it, saying it's available, but I'm going to wait and write that later on when I write a class that's more specific to area. But some things that I could do is I could get x and I could return the x value. I could get y and I could return a y value. I can move the x and y to a different position. And of course, my good old overridable method toString. If I want to print out an abstract shape, I am going to print out the position of this point, and I said the area too, just because I want to show you how to use that in your other class. So I'm going to go over here to the rtriangle.java class that I wrote. Now notice how rtriangle extends abstract shape. This class has to have, now notice how I'm using the super keyword from the last unit, from the last video that I made, because everything from abstract shape gets inherited by this right triangle or our triangle class. Make up some bogus height and bogus base because it doesn't matter now. Those are probably going to change, but this is just a constructor. Or if somebody wants to construct it by sending a point, a height, and a base length, then that's fine. But now here's where I really need to include all of those definitions for what area means. So area means this for a right triangle. Draw means this for a right triangle. Stretch by a certain factor means this. But now I could have other, like I could have a square class. I could have a circle class. I could have any number of classes where stretch by would have a different definition under it. It would do something different. It would have a different formula here. And then of course I have my good old toString method, my overridable method. But notice how here I'm using super.toString. So that means I'm jumping back to the abstract shape and I'm printing this out. So that's what that super dot will do here. Super.toString calls on toString from the abstract shape. So it's a lot to keep straight, but I would really encourage you to take a close look at the comments that I gave you in the keyins themselves, and also look at the document that I gave you, the PDF that's available for you in Moodle, because that also kind of goes through and talks about all of those features of abstract classes and interfaces. I also have some information in there about throwing and catching exceptions, and I do give you an example of that. You should be aware of that and make sure that you're using that information. And then look at the keyins and make sure that you're paying particular attention to the comments in those keyins. I know this is a lot. You guys are getting like 4 programs now for the price of 1.